All right, there, ladies and gents, let's go and get started. So the purpose of these notes is to help clear up any kind of misunderstandings, at least the technical misunderstandings from the last couple of days of class, or at least put you in a position where now that you thought really hard about like the nature of translations and what they're going to do for us, you're able to actually do the mechanical parts performing them. Because in the end, if the big question is how do you prove things are congruent, and then one of the big obstacles we had was like how do you know you can move a shape around a plane without changing the shape at all, then at some point, I'm going to ask you to actually perform these, right? So the last couple of days were devoted to just understanding that translations aren't going to move things and explaining those in a really nice way using like the rule and the structure. And uh, and so this is an opportunity, like I said, to get like to make sure they have the absolute right technical pieces, so you're not doing at least recording things incorrectly. Anyway, so let's get to it. So of course, hopefully by now you had this all copied down. If not, pause the video and get it, because we're gonna need to jump right into the notes. So the very first thing we need to talk about is how can you identify, or at least notate a translation has actually happened. So the notation actually happens several different ways. There's actually four total ways I'm going to show you. The first way is the algebraic rule way. Now this by far is the most like middle school way to show that translations happened, or at least to note it. But this is also one of the most logical and straightforward and natural ways to show it. So a translation has to happen to all points in the plane, not for one point at a time, but for all the points. So one rule suffices. So this is just any point x, y in the plane undergoes a transformation. I'll try to color code a little bit here. X plus a, oops, and then y. Let's go a different color. Plus b. So this whole idea of plus a plus b is just kind of how it's changing. And the pluses, of course, can become minuses depending on what you want to actually happen. So like this a, the way to interpret it is the movement left and right. Now, of course, this should make a whole lot of sense because it's attached to the x, and the x is the left and right movement on the graph. The b movement is the up and down movement, and for the same reason, this should make sense. Y is the up and down axis, so up and down movement if I affect b in some way. Now, in terms of like the plus and minuses, of course, like left should be the minus. So if I'm subtracting a number from x, I'm moving it more negative. Right, I'm moving more positive. Same thing here. Up is plus, minus is down. So if I have a rule, let's kind of put it right here. So kind of as an example, if I have this rule like all the points in the graph, x and y should move like x minus 3, uh, y plus 2. That means it's moving down 3, and this is moving up 2. So if I were to throw a grid down here, and again, if you, I switched to the gridded notes because it says on and off the coordinate plane. So these notes are this template's available in the Google Drive, also my homework if you want to use it. And I'll have them printed out here in class as well. So if I just pick some points, by the way, let's say I pick this guy right here. Let's call it A. I'll pick this guy here. Let's call it B. And pick a point here called C. If I want to use this transformation rule to move it, this says move all my x's back 3, like left 3. So this is going to go 1, 2, 3, and then up 2, 1, 2. And so this guy right here is going to be my a prime. Let me move this rule. Okay, sorry about that. Anyway, so it's going to move back 3, 1, 2, 3, then up 2, and that's going to be my a prime. A prime just shows the image point of A. So if A is my pre-image where it was, A prime is my new image where it is now. All the points would have to move the same way, so B would move the same way. So back 3, and then up 2, that's my B prime, and then 3 up 2, there's my C prime. So if I kind of compare like this shape to this shape, they should be congruent. That's something that you guys have identified for us. But that's basically the movement. Now, this isn't the only way to describe this movement, of course. Like if I were to take and look at A, I can certainly describe its movement to A prime as back 3 up 2. I can also just say it moved on this direct line from A to A prime. In the same way, I can say B moved back 3 up 2, or I can say B moved along that line and along that line. Now, if you notice, I'm putting the single arrowhead on there intentionally because this line, used in this way, is actually called a vector. And a vector is nothing more than a direct path to something. So, like if I were to walk in the room from the door to the back closet, I'd be moving in a vector because I'm moving in a direct line a certain distance. And that's all vectors are, a direction and a distance. So that actually is a whole other way I can explain, excuse me, I can explain my movement, which actually leads to a second way I can record the rule. So the algebraic rule is fine and dandy. It is a little middle schoolish. It's nice to start thinking, but we have to move into something more technical. So the second way I can record this is by vector rule. And vector rule actually is the same exact thing as the big algebraic rule. It just has it's a little more straightforward. So first of all, I'm going to use these brackets. That's a dead giveaway that those are actually going to be vectors. And then I just use the changes within the vector rule. So if you notice, what I'm saying is it means the same thing as your algebraic rule. It has the same pieces. It's just more direct. And so like this still means move plus or minus A, plus or minus B, whatever it happens to be. Um, so like if A is negative, you move down or back. It just does it in a more concise way. So if I come over here to my grid, this rule is totally fine. Like that will totally make sense. I can also say take A, B, and C and move them along the vector, in this case, minus 3, comma 2. And so like that is an equally good way to identify this change of these 3 points. So I have the main rule, or the algebraic rule. I also have this vector rule. Now there's levels of sophistication on the vector rule, a couple variations if you will. One is the formal translation rule. Okay, so the formal translation rule takes this vector notation and the algebraic rule and kind of mesh them together. We use a little t to indicate a translation. We subscript it, which means attach it kind of in the bottom small to the t, the vector rule, and then we say that it applies to all values x, y, to our new point x prime, y prime. So this by far is the most kind of the most formal version of how to show this. But it says the same thing the other thing says over here. And again, it incorporates all the parts. So like this just stands for translation. And please make note that it is a lowercase t on purpose. That is a vector of movement. This is our preimage. And preimage just means where we were. And that is our image, means where we're going to end up. So the reason this is formal because it incorporates all the parts. So um, over on this, we can certainly write it that way. We can say, I want you to undergo a translation along the vector negative 3, 2 for all the points x, y to go to our new points x prime, y prime. And then I could feed those through. I could take each of A, B, and C, feed into my rule, and come out with like the actual points. One more way, and for good news, this is actually just a little bit shorter. This is a shortened version of the formal translation rule, and that is what I call the generic rule. And so instead of a lowercase t, which specifically means translation, we're going to use uppercase T, which is going to mean generically any transformation. We are going to recycle the vector notation. So this is going to be A, comma B, and that's it. So just like the last rule, this is going to mean the generic transformation. So we can use that for like reflections or rotations. And this is going to be the vector of movement. But the other part is somewhat unnecessary, so we don't actually use that. So going over here, we can also describe this as, let's keep the color coding together. So the translation along -3, comma 2. So those are all different ways to describe the same thing. And again, I guess this isn't super important. It's just really points to points. I wouldn't think of it as shapes. Just points to points are good. So those are all ways we can notate a translation. Excuse me. So that's kind of like all that rule-based stuff. And again, the whole idea here is that the algebraic rule is good because if I add to the same points, the spacing really does stay the same. We described it using like slopes, parallel lines, which is a good way to think about it too. So let's put a little break in our notes. That was purely like a rule identification. Let's talk about a structural identification. So allow me to put a new example up here. So what I mean by structural identification, let's just say I pick up some points. Let's call it X. Well, X is a bad idea. Let's call it A. Let's call it A, and let's say this other point up here, let's call it B, and then C. And let's say A, B, and C go through some kind of translation. Let's say the vector is going to be 4, comma, -3. So it's going to be, just for notes review, this is going to be over, well, right 4, and that's going to be down 3. And so I can just count this out on the grid because that's okay to do here. So right 4 would be 1, 2, 3, 4, and then down 3, 1, 2, 3. So that's A prime. Let's do the same thing to C. And then B. Okay, and so the interesting part here structurally is not what happens as A, B, and C are a shape, but rather what happens when I take A to A prime. So I'm going to examine that vector again. Now you might have noticed on the other one that if I look at the vector um, one piece at a time and compare them, but compare them to like the C prime vector and the B prime vector. Two things hopefully you're noticing. Number one, that these are all the same size, which should make sense because if I'm just sliding all the points the same way, they should end up moving the same amount. But something more than that is that these actually end up being parallel. So like if I can just take this and copy it and slide it over just like with the points, those are all end up being parallel, which is actually a really important part of the structural explanation. Because if you think about the definition of parallel lines, it's not that they never touch, as some people keep trying to say, but rather the spacing is the same. So all translation vectors it's weird. There we go. All translation vectors are parallel and congruent. So congruent sign and parallel. So if you consider like the definition of parallel lines, this is really important because they're equally spaced, again assuring us that we can do a transformation, not change anything. So if we can explain that no distances are changing by the transformation rule, the translation rule, and also that they all have to move along parallel lines, that leads us to one really important conclusion in which we can identify transformations as what we call rigid transformations. So these three dots mean therefore. That's just math speak. So therefore, translations are rigid motions. Now that's a key terminology phrase that we need to get familiar with. Okay, so what I mean by rigid motions, I can give you kind of a example, but I'll first give you like an interpretation. Rigid motions are same thing as congruency transforms. Which are the same thing as saying Okay, so the same thing as saying whatever shape is transformed does not change. So if I call this translation a rigid motion, what I'm basically saying is no different than say like a car, or like a bus. So like you when you, in the morning, let's say you ride the bus to school, you get on the bus, you're you. The bus takes you to a different part of the city and drops you off. But when you jump off the bus, like you don't change it to a different person. So like you don't enter the bus as you and then leave the bus as like Miley Cyrus, which I know is kind of a silly example, but that's what I mean. Like you are who you are before and after you leave the bus. So the bus itself is like that transformation. It just takes something from one place to the other. This is a really, really important point that I don't want you guys to kind of like put in the back of your mind and forget. I want you to kind of always be thinking about this. So translations do not change anything. They simply move what you already have. So it's not like this magic thing that's gonna like blow it up or shrink it or what have you. Whatever you put in is exactly what you get out. Like in the same way, like when you go into a car and then leave the car, you're still the same person, at least physically, hopefully, right? So a couple things we need to do now. Number one, you need to get your summary together, put it in your notes, and I suggest you do it right now. Some people are skipping that part. It's not good. You remember stuff when you write a summary, so I want you to keep doing it. But if you're confused about how to actually write a summary, here's the best way to think about it. Just pretend a friend has just texted you, is asking about translations. What are you going to text them back? This kind of three-step process, at least two-step process, is going to help you do that. Because if you're texting stuff and you don't use a word like rule or parallel or preimage and image or vector, you're probably not texting good stuff back. So that's the whole point of rereading your notes and highlighting stuff, is to make sure that you hit like the really, really important vocabulary, because your friend's going to want to know that. In terms of posting at Edmodo, people got lots of bonus points on the test for this. Like it went up like between 1 to 5% depending on how much you posted, how good the stuff you posted, and what you had in your notes. So make sure you're doing that. Now, a second thing is, you notice I didn't fill in these questions. It is now time for you to start filling in the questions. So really pay attention to the notes, and off to the left, write the question that would go with the notes. So that's your time to start doing that. It's appropriate. So that's all I have for translation notes. Now let's look at a couple examples before we cut this off. So here's a common question that I'm going to have you guys do just now in class. It's actually one of the recommendations I'm adding to like your quiz. But this is pretty simple, so let's kind of look at it here. So what was the translation applied to move the blue solid shape to the gas shape, so from blue to orange? So the best thing you could do is kind of like just pick out a point, like pick out this guy like right here, and then move it back. So just count this movement, because you know a couple things. Number one, you know the translations apply to all points on the plane, so you don't have to try to track all the points. You just have to track one of the points, and the rest will move the same way. Also, you know it's rigid, so you know if you just track one point, the shape should stay the same. So we're moving blue to orange, so let's check this out. So we're moving, let's see, 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3. So we're moving back 7, up 3. So if we're moving left on the axis, it's -7, and then a +3 should be up. Hopefully I counted right. Hey, look, I counted right. Let's see, this variation, same kind of thing, blue to orange. So let's count again. Again, I'm just going to take the top point here. So that's going to be 1, 2, 3, and then 1, 2. And so we're going to move back 3, and then we're going to move up 2, and then we got the transformation. Again, blue to orange. So I'm going to take this crazy looking point because it's super identifiable. I'm going to move down 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to move over 1, 2, well, I lost count. Yeah. So 1, 2, 3, 4. So moving right 4 and then down 8. So it should be 4, down 8, down negative. That's why I'm putting that as negative. Looks like I passed enough here. There's a couple more variations just to be able to see if I can trigger one. Oh, here's one. So here they're actually telling you the translation up here, again in that generic transformation notation. So big T in this case stands for translations, and then of 0, 3 to be the vector. This isn't in vector notation, but it means the same thing. So 0, 3 would be to the right 0, so I can just drag it. But I'm not dragging anywhere because it's right 0. Then 3 for the Y means up 3. 3, boom. Check it. So let's see if I can trigger another one. Nope. Let's just do this one really fast. So instead of counting, you can also just look at the numbers. So this is -1 and needs to end up at -7. So that means I'm going to move it to the left 6. And then, let's see. This goes to 2 and has to end up at -5. So I'm counting right, that's down 7. So my vector translation is -6, -7. I'm trying to get another one I can move. Blue to orange. So -3 to 2 should be right 5. And then -1 to 1 to -1 should be down 2. Man, they're just not cooperating. Blue to orange. So 1 to -4 should be -5. And then 4 to 2 should be down 2. Here we go. So here's another one that I was looking for. Translation of 8, -4. So 8 means over to the right 8. So 1, 2, 3, 6, 7, 8. 8 and then down 4. 1, 2, 3, 4. And of course you want to be, oh, I miscounted. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8. And we can confirm it was at -3. Now I'm at 5. Yep. Then down 4. All right, there we go. And of course, that's a good demonstration of mistakes that could happen if you're not kind of checking your work. And just like a lot of times it gets frustrating, that was my 5th one in a row. But we're going to stop it there. So this assignment is one that I'm assigning you Khan Academy. It's already there for you. It's under the recommendations. It's part of the kind of quiz cycle or the Khan Academy quiz I'm giving you right now. All you have to do is clear it. So you see it's not much to do. There are a couple questions I want you guys to answer and follow up and then send it to me. So go ahead and do that. And there's a couple more note sets for you, but that's all I have for now. Thank you.